do a worksheet, but it's really the material from section 3.2. And then tomorrow we'll go back into the book and do this material from section 3.3. And then we'll do a review on Wednesday, just to really get you comfortable with all the different things with factors and divisibility, prime numbers. So we have a lot of goals. So we've got this vocabulary list over here from last week, and we're going to add to that prime numbers. Okay? So Kyle said, I love prime numbers. Can you tell me some prime numbers, Kyle?
Prime numbers,
2. Most people don't remember that's a prime number. 2 is a prime number.
2 is 3, 5, 7, 13,
Okay.
17.
Okay, so listen to all the numbers he's coming up with. 5, 7, 13, 17. So somebody else, give me a non-example. Example, something that's not prime. Michaela? 9's not prime.
Oh.
You're right.
Oh, yeah. It's in one.
And why is 9 not prime, Michaela? Do you know?
I worked on this a long time ago. So I don't.
Can't remember?
Yeah.
Who can tell us why 9's not prime? Yeah, I know Kyle can. What about the rest of you guys? You guys don't. Okay, Kanan?
Well, a prime number, it only can be made by 1 in itself.
Okay, so do you remember we talked about factors last week? That was one of our vocabulary words. So factors are the numbers that divide into a number. So the only factors of 2, the only way to get 2 with multiplying is doing 1 times 2. And the only way to get 3 with multiplying is doing 1 times 3. And the only way to get 5 with multiplying is 1 times 5. So that's why these are prime numbers. And the only way to get 7 is 1 times 7. So on and so forth. But on 9, you can do 1 times 9. But you can also do 3 times 3. So if you could come up with more than one way to multiply to get the number, the target number, like the target number here is 9, then we know it's not prime. So Eric, what's another example of a number that's not prime? Let's say less than 20. 4. 4 is not prime because you could get 4 with 1 times 4, but you could also get it with
2 times
2 times 2. Isabella, pick a number between 20 and 30 that's not prime.
Well, isn't 1 a prime number?
Yeah.
25. So we'll talk about 1. That's a good question. 25 is not prime because you could do 1 times 25, but you could do 5 times 5. So Kanan, the question is, isn't 1 a prime? 1's the exception because the definition of a prime number is a number whose a number that has 2 factors, 1 in itself. So they have to be different factors. So a prime number, we'll write that up here. Has exactly 2 factors. And they have to be 1 and itself. I'm going to run out of space here, but I'll fix this in a minute. So see if it recognizes my writing. Almost. A prime number has exactly 2 factors, but that should say 1, right?
Because it's the teacher's there. Oh, yeah, it is. The teacher said it to school. I think it's supposed to be too. Oh, never mind.
So do you guys understand that? So it has to have exactly 2 factors. 1 has to be one of the factors, and then the number itself has to be the other. So 1 isn't a prime number because it doesn't have 2 factors. Right. Well, let's talk about generalizations. What could we say? Who could complete all blank numbers
We're supposed to be writing this down.
Yes, take some notes. Except, who can raise their hand to fill in the blanks to that sentence of things that are not prime? Michaela? Sure? Anybody? You want to try, Michaela?
All odd or even numbers.
One of the two.
All odd, all even numbers.
All very good. All even numbers are not prime except for
Two.
except for 2. Great. I didn't take a chance. Okay. But primes can be prime number. So the only even prime number is 2. But not every odd number is prime, right? Like 25 is not prime. Neither is 9, right? So you want to be careful when you pick primes, but you're looking for factors. You have to kind of, think about your factors, and so we're going to focus on factors today. Can you guys raise your hand if you understand the difference between a prime number and a number that's not prime? Okay. So we have a word for the numbers that aren't prime. So these numbers over here are primes. And these numbers over here are called composites.
How?
So that means they are composed of more than 2 factors. Okay, they can be written out with more than 2 factors, more than one way. So we're going to look at some skills that you're going to do today. So I'm going to try. You guys have this copied down?
No.
Okay, you should copy it down. Let's go to a 2-page view for a minute.
Is 23 a prime number?
23? Yeah, so we're going to figure that out. We could put 23 on our list, or what do you think about 23 right here? What do you guys think, prime or not? You think it's prime? Can you think of any other way to get 23 besides 1 and 23? No. So 23 is prime. So what we're going to do next is look at this list here and talk about how to list all the factors kind of in a systematic way.
Is 32?
We're going to, well,
Oh, no, it's not.
okay. So let's talk about that. So watch what I'm going to do. I'm going to take the numbers 15 and write all the factor pairs out. Okay? So I'm going to add in a piece of scratch paper here. And when I look at the number 15, I'm going to think of all the ways I can get 15 in a really systematic way. So I'm going to start with 1, because 1 goes into every number. And then I'm going to go up and say, is it even? So 2 doesn't go into it. Does 3 go into 15? Yeah. 3 times what? 5, right? And then does 4 go into 15? No. And then does 5 go into 15? Yeah, right? We just see it there. So 5 times 3. Once you see this repetition, and you'll understand a little bit more what I mean in a minute when I do it. If you go in a systematic way, where you go in order, that's a really good way to find all the primes. Oh, I mean all the factors. So over here, I can list the factors in order. 1, 3, 5, and 15. So 15 has 4 factors. Okay? So because there's 4 factors, we call 15 a composite number, not a prime number. Does that make sense? So let's look at, so we're going to call 15 a composite. Let's look at 18. Going to do the same thing. 1 times 18, is it even?
Yeah.
Yeah, so Quinn, 2 times what is 18?
6.
Close.
Wait, 9.
9, right? Does 3 go into 18? Yeah, Andrew. 6 times. Does 4 go into 18?
No.
No. Does 5 go into 18? No. Does 6 go into 18?
Yeah. Yes.
3 times, right? Do you see that I'm now repeating factors? So if I've gone in order, all of these numbers here and all of these numbers here should be my complete list of factors. So I'm trying to be very systematic. Your elementary school teachers might have done something called a rainbow. So watch, if you write them in order, 1, 2, 3, 6, 9, 18. Your elementary school teachers might have shown you something like this. 1 times 18, 2 times 9, 3 times 6. Did they ever do that?
Yeah.
Some maybe,
Yeah.
some didn't. So it's the same thing. Okay? So you want to come up with all of the factors. Kyle, did you have a question?
I see that you already kind of did that with 6 times 3 technique, but like, because you already did 3 times 6, so you don't need to do 6 times 3.
Right. So what I'm trying to show you is once you start getting a repeating pattern, if you've gone through all the numbers, you probably, you should have found all the factors.
Yeah. And also, if you can't go about half.
Good point. Right. So your factor can't be more than half the number.
Yeah.
Unless it's itself. A really good observation. So Kyle, is this a prime number or a composite? It's a composite. So with 18, we're going to call it a composite. Okay, so what about the factors of 5? Nick, what are the factors of 5?
10.
No, not the multiples, the factors.
Of the factors.
How do you get 5 with multiples?
5.
1 times?
Yeah. 1 times 5.
And? Is that it, or are there more? That's it, right? So what kind of number is 5? So the two factors of 5 are 1 and 5, so we call it a prime number. Okay, Andy, what about 2? What are the factors of 2?
1
1, anything else?
and 2.
And 2, right. So what kind of number is 2? Prime. Okay. Sarah, what about 17? 1. Anything else? 17. So what kind of number is that? Prime. Okay, what about 4, Emma?
1.
1 times? 1 times what? 4. Is it even? So 2 times? 2. Do we see the same number twice now? So there's repetition. So these are the factors. Anytime you get to repetition, you should have found all the factors. So what are the factors, Marcos, of 4?
1, 4, and 2.
Right, and so put them in order, 1, 2, and 4. So Marcos, is 4 prime or composite? Good. Okay, Claire, what about 16?
1. And then there's always 1.
So once, that's right, oh, there's always 1. So for 16, whoops. For 16, 1 times 16, what else? 2 times 8. Does 3 go in? How many times? No. So cross it out. But we should check, right? What about 4? How many times? Do you see repetition? Yes. So that means here are your factors. So list the factors from low to high. Claire?
1, 2, 4, 8, 16.
Great. So is it prime or composite? Nice. Joe? What about 27? about the factors of 27?
1 and 27.
1 and 27. Does 2 go in? Does 3 go in?
Yeah.
How many times?
9.
9. How about 4?
9.
5?
No.
6? 7?
Yeah.
Yes?
No.
No. Anything else? 8? 9?
No. Oh, yeah,
9 times.
9.
There's your repetition, right? So that means we found them all up here. 1, 3, 9, and 27. Do you see what I'm doing, you guys? I'm trying to be really systematic, so once you see the same number twice, you've found everything.
Yeah.
So Eric, what are the factors of 27 then?
1, 3, 9, and 27.
1, 3, 9, and 27. So is it prime or composite, Eric? Composite. Okay. So that's part of your work today, is deciding if a number is prime or composite. Okay. You guys have some examples written on your notes there?
Yeah.
So the next thing, am I going too fast? Good. How about if I turn the page where you can still see it?
Yeah.
Raise your hand if you know what a factor tree is. What's a factor tree, Michaela?
So it's where you, so like with the 56,
Yeah, with the 56 over here.
you would draw like a carrot,
Okay.
and then you would put the prime number, like if 6 is a prime number, you put it down there, right?
Right. I didn't really mean to have the same number twice here. Let me change this to 56 and about, 24. Okay, so she's sort of talking about a carrot. That's a good way to describe it. Little upside down carrot. So you take your number. I bet more people know this than just Michaela once you see what she's talking about. And you find, oh, I know why I have 56. I kind of might maybe do want that. There's a reason I have 56 twice.
Okay.
Because you could do a factor tree more than one way. So let's look at a factor tree of 56. You find 2 numbers that multiply to give you 56. Andy?
7 times 8.
Good. 8 times 7 or 7 times 8. So the little carrot that Michaela's talking about, every time you use one of these little V's or carrots here, the numbers at the end have to multiply to give you the original number. And then you look and say, can I do that again with something other than 1? Like 7 is a prime number. So the bottom of your tree, you want to stop when the bottom of your tree has prime. So since 7's prime, you stop there. But 8 is not prime. So you do the factor tree farther. So what's 2 numbers that multiply to give you 8? Claire? 4 and 2. Okay, so Claire, are any of those prime? Really? They both are? Look at our list. Here's 4, and here's 2. 2 is, and 4 is not, right? So that's the bottom of the tree branch for 2. But for 4, Joe, how can I get 4? 2 times 2. Okay, so now you have all prime numbers at the bottom of your tree. So a lot of people use this technique, and I think it's a really good idea, to just move them down to the same level so you don't lose track of them, like this. And you have 7 times 2 times 2 times 2. That's the prime factorization of 56. So what that means is, can you write 56 in a way that you're multiplying only prime numbers to get to 56. And usually you write them in order. So you'd say 2 times 2 times 2 times 7. Okay? Check it with the calculator. We do a quick check with the calculator. When I do 2 times 2 times 2 times 7, what number should I get? 56. Okay, so when I multiply my answer back, I should get what I started with. Okay? The reason I had 2 factor trees is you don't have to start with the same. This is called a factor pair. 7 and 8 are a factor pair. You could have started with something else that went into 56. The tree could look different and get the same answer. So what's another way, Kyle? 2
and 33.
2 and
2 and 28.
28. So it's a little harder to think of that factor pair for some, I think. 2's prime, right? So we're going to circle that. But 28, I can keep going. You could do 2 again. 2 and 14, right? So 2's prime, so I'm going to circle that. But 14's not. What's 14, Nick?
7 and 2.
2 and 7, right? So 2's prime. How about 7?
Yep.
Yeah. And so when we do the arrows, we just bring these all down to the same level. I still get 2 times 2 times 2 times 7. So that's the prime factorization. It's writing the number with all primes and a multiply.
It looks like buildings.
Looks like buildings
Yeah, with the roofs.
with the roofs. Yeah, kind of does, huh? Little houses. Okay, has anybody, well, we should probably stop there on that one. Let's go, let's talk about the worksheet. Well, let me ask you one thing. Does anybody remember what an exponent is? Michaela, what's an exponent look like?
It looks like it's 2 on top of it.
Looks like a little number, right?
That's
So for 56, the prime factorization of 56 is 2 times 2 times 2. So since there's 3 2's, you could write 2 to the third times 7. And that's the goal, that you guys could write this using exponents. So on your sheet of paper, I want you to find the prime factorization of, how about 36? So find the prime factorization of 36 using a factor tree. And then I'll walk around if you need help. Let's see. Who haven't I heard from today? Pretty much all of you guys. Want to start me off, Andy?
Yeah. 9 times 4.
9 times 4, okay. Sarah, did you use 9 times 4 or did you do something else? You used 9 times 4? So then continue. What would you do? A little louder, Sarah.
9 can split up into 3 times
3 times 3.
3. And then 4
Uh-huh.
can be 2 times 2.
2 times 2. So those are all primes, right? So your prime factorization is,
3 times 3
so go in order,
2 times 2
2 times 2
times 3.
times 3 times 3. And it's not going in order. The reason I say to do that is easier for everybody to compare answers. It's not wrong to have it out of order, but it's a lot easier for everybody to compare their work if it's in order, so we usually try to put everything in order. Okay, Kanan, can you do this prime factorization now with exponents? So do exponents. Rewrite the prime factorization with exponents.
3 times 3 times 2 times 2.
No. Nick?
Isn't that, 2 to the third?
Not quite. How about you, Quinn?
2 to the second.
So there's 2 2's, you guys, right? So 2 to the second times
3 to the second.
3 to the second. Good job.
Oh, that's what it was.
That's what I want.
Just the difference.
Exponents. So these little numbers here, remember these are called exponents.
Oh.
So you want to practice writing in exponents today.
Does that mean squared though?
Mm-hmm.
Well, 2 squared is
2 squared is 2 times 2. Okay, so I'm going to pass out this worksheet here. If you need to keep writing your notes down, you can do that while I pass the worksheet out. This is the worksheet, and we'll start this together. And then you can finish it for homework. Okay, you should have this worksheet in front of you now. So Mark, what's the definition of a prime number? How could you write a definition there? A prime number is a number.
That's times it by 1 in itself.
Okay, how are you going to say it? A number whose, use some of the other vocabulary words like this one.
The only factor.
Right,
The only factor is 1. So
good. So a number whose factors are 1 in itself. Whose only factors, right? A number with only 1 and itself as factors. So what's the composite then? What's the easiest way to write that, Joe? A number that has
more than 3 factors.
more than 2 factors.
Yeah.
Right, you could say it that way, or a number that's not. What? A number that's not. Right. So a number that has more than 2 factors would be perfect, or a number that's not a prime. Except for the only problem is, what's the special case? Well, no, that works good. A number, that was me, just me. A number that has more than 2 factors. So when you get to problem 3 through 13, you just answer prime or composite. So your answers are just going to write prime or composite. We're not going to do samples there. You guys do that for homework. I wanted to show you this though, because make sure you understand these are factor trees and I'm starting them for you, so you have to do the way I'm starting them. So for example, here I'm saying 28 is 7 times what? What would have to go in the other spot, Eric? 4. Okay, so for Marcos, if 4 is here, then I have to keep going. So what would have to go in the spaces below? 2 and 2. So now you're just finished your factor tree. What's your prime factorization, Marcos?
2 times 2 times 7.
So you write that here, 2 times 2 times 7, and can you write that with exponents?
Wait, do we have to write that part?
Yeah, where it says prime factorization, just right next to it. So what's the exponent form? Yeah, Nick?
2 to the second
2 to the second.
times 7.
Perfect. That's your final answer. Okay, you understand that section? Yeah? So go to the next slide. Woo, gigantor. So on the next side, you make your own factor trees. Okay, so 58. Does 2 go into 58? 2 goes into 60 how many times? Let's talk about that. 30. So 2 has to go into 58 just a little bit less. How many times? 29. Is So is either one of those numbers prime? 2 is prime? Okay. So then how do you get 29 with multiplying? Michaela?
Does not 10, but 9. Can you
9 times 7 is 20. I mean, 9 times 3 is 27, so 9 doesn't go in.
just 2 go into 20?
It's not even, so 2 doesn't go into 29.
What about 3?
3 times 7, 3 times 9 is 27, so 3 doesn't. 8 times 3 is 24. What do you think? It's prime. So that's the shortest factor tree you could have right there. So, Joe, what's the prime factorization? Right, so 2 times 29. No exponents, just 2. That's the whole thing. But it has more than 2 factors, right? Because what are the other factors? Even though you don't put them in the 1 and 58, right? So it doesn't only have 2 factors. It has two numbers in the prime factorization, 2 prime factors. Raise your hand if this makes sense. Okay, so you guys have a little bit of time to start. Why don't you work on that and take the rest home?